Good morning to everyone. I'm Giovanni Vignali from University of Tuscia. I thank the organizer of the conference to allow me here today, and I will present you an application of machine learning models for algorithms to evaluate the effect of climate change on livestock product. But why climate change is so important? Nowadays, as we all know, the climate is changing and is producing more and more, how can I say, very extreme events. For example, heat waves in summer, as we all have experienced in the recent years. How the climate affects our everyday lives? The discomfort index, which has been referenced first time from Tom and Bosens, identify two variable inputs, air temperature and relative humidity, which are used to describe a discomfort zone. If you've got low value, in this example, as we can see, less than 21, you are in the green zone, which is very no discomfort. And as the value of the discomfort zone is higher, we are more and more discomfort as we arrive at value which is higher than 32, we are in very critical state. This discomfort index has been used for human, and we are also the temperature humidity index, which is used in the zootechnical field, is very useful to understand how the climate can affect the livestock. Why? So it's very important. As we can see in these pages, we have a discomfort which has been measured for the 1991 to 2020. From 2021 to 2050, we have compared how much the discomfort will change. And as we can see in these pictures, we have a higher level of discomfort. So we will be in a more severe state of living as human, as this is this plot, but as I can see in the previous slide, this will also affect the livestock. But what will happen to the livestock product, for example, milk? This will be a change, or it will remain constant in the future? To do so, we have pre-processing the historical data, which are climate data we have gathered, and we also gathered the milk yield in the last years. We have created an algorithm which analyzes this data and can estimate the production in the future year using weather forecast. First, which data we have input? In our study, we used Pezzata Rossa, which is a breed which is very common in Friuli Venezia Giulia region. It's a region which is in the northeast of Italian country. We have 2.3 million of functional control. This functional control came from more than 100,000 animals, and we had more than 1,000 farms which are our partner. All the data we gathered, we used to create a fixed model to obtain a residual value. And in this fixed model, we analyze specific aspects, for example, aging months of the cow, which affect the quality and quantity of milk to produce. All this data have been gathered through our pattern, which is AYA and ANAPRI. The climatic variable data that we have collected are being given us from our pattern CMCC, and we use 9 different variables, which are temperature, mean, minimum and maximum, relative humidity, we also take mean, minimum and maximum. We take cloud cover, we take also precipitation and wind speeds. All these variables that we have collected have been taken from the day of production up to 22 days before we have calculated our models. So we have a huge quantity of data to analyze through our machine learning algorithm. How can we process such huge amount of data? First, we have done a recursive feature elimination, which will help us to understand how important is the variable that we are using. We have selected from, after this model, the top 100 variable, And we have used to calculate the importance the mean absolute error. This is a way to evaluate how good our algorithm is when you do prediction, because lesser is the mean absolute error, more accurate is the prediction that we will make. And in this first 100 variables we have selected, we have noticed that wind speed is very rarely present. So it's one of the not most interesting and important variable for the model that we are building. We will use, as the second step, we have used H2O AI to find the best algorithm. Each has been divided in 2 steps. First, since we have do algorithm selection to test different algorithms to find which one is the best for our model. The result we obtain is gradient boost machine is the most precious one of the model that we have obtained. Second steps, we have doing a grid search. Grid search is very important to optimize the hyperparameter of our model. For example, such as shifts of the number of positions and others more technical aspects of the algorithms. Next one, we have the feature selection. After we had our model, we need to select the features. How have been pursued in this point? First, we have ordered the features by importance, and second, we have calculated the mean absolute error of each feature. The feature that we have calculated, at certain point, there have been no very change in the mean absolute error. This means that the feature we have selected are the most important one, because when we have 100 features, it's too much to have algorithm working. It's better to select the most important features to have more concerned data, and also is more easily applicable. And at the end of this process, when we have selected the most important features, we obtained it was 15, the best number of features. These features, as we can see, there are usually temperature and relative humidity, which also in literature is one of the most common variables in the technological field, which are indexed with animal livestock production. How the feature explanation, how a sharp algorithm can explain the importance of the features. We have the 2 colors, one is red and one is blue, which is at the extreme, and we have a gradient between these 2 colors. More points tend to be red, it's more higher value of the value. For example, for Tmax mean, we have got higher value of temperature, and we have blue color for lower level of temperature. And for this, we have a very interesting. This means that we have Tmax each higher temperature for a higher production, but in 22 days before, it was the opposite. This is very interesting results. And how we have applied these machine learning models? We have a construction of risk maps, which takes in assumption the past data and the future data, and we have compared using our algorithm. So we could find that measuring the years which go to 1990 to 2020 and the future maps which go to 2050 to the to 2021 to 2050, this will help us to understand how the production is going. So, as we can see, we are reducing of the production, which is quite interesting, and the climate change are affecting also the livestock product. In conclusion, the pipeline is a generic one. It can be used to different fields, for example, economic one. This is not the place where to explain economics, how is it work, but it also can be used in this purpose. We have also other climatic data can be used, not only the one given us for our partner CNCC, but also other partners, for example, ECMWF, which gives weather forecasts all around Europe. It can be also used. And as I've seen before, the climatic data, the model we have produced, will show us that we have a reduction of the milk which we produce in the future. This is thanks to Sebastian, Agritech, and Highlander, which is our partnership and financed the project. Thank you for your attention.